Welcome back. This is the second lesson recording for IM1, April 27, 2021. The last recording did not show what I was trying to show, so I'm going to do that again. So does the figure have rotational symmetry, and what is the order of rotation? Well, if I was to trace this image here, okay, and if I was to start turning this like so, okay, when does it match up exactly? Here we go, bam, it matches up exactly right there. Okay, so then I keep doing that, and then it matches up yet again. We still have not done the first turn yet, and then this is the third time when we reach the full rotation or full turn. So it matched up 3 times before we made the 3 turns. So that tells me that yes, this image has rotational symmetry, and the order of rotation, because it matched up 3 times, is 3. What about this image? What do you think? Does this figure have rotational symmetry? Think about it. Now, if I was to trace it again, can I turn it in such a way it will match up exactly? I'm turning and turning and turning. It's not matching. It's not matching. It's not matching. Okay. And then finally, when I get to full turn, it matches. Okay, but think about this. Any image is going to, when you do a full 300-degree turn, it's going to match exactly. So this does not really make, this does not count, matching after one full revolution. So we say that this shape or this image does not have rotational symmetry, and having it match after one full revolution does not count. So we need the order of rotational symmetry to be at least 2 for us to be able to say that a figure has rotational symmetry. And now you're going to be working on card number 7 to 12 of Desmos. Here we go. This is card number 7. Okay. Does this image have rotational symmetry? Well, if I trace this and started turning, does it match up exactly? Notice that red mark tells me where the top is. If I start turning and turning and turning, does it match up exactly? Here we go, bam, it matched up exactly once, and twice, and then 3 times when we've reached all the way to where we started it, okay, where the arrow is at the top. So we've matched up 3 times. So yes, this figure has rotational symmetry, and the order of rotation is 3. What about this orange segment, orange slice? Okay, if I was to trace the image, if I start turning, does it match up? Yes, exactly right there. That's once, twice, 3 times, 4 times, 5 times, oops, and then 6 times, 7 times, and then 8 times. Okay, so if it was a more complicated image, okay, you're really not going to be tracing it and counting it. Where does the number 8 comes from? It comes from the fact that we needed to match each of the segment inside, and there are 8 repetition of the segments, 1, 2, 3, 4, 5, 6, 7, 8. So that's the reason that order of rotational symmetry was 8 for this case. What about this shape? Can I turn it in such a way it will match up? No match, no match, no match, no match, no match, and no match. And we've made a full turn, and the only time it matches is after a full turn. So the order is 1, and therefore we do not count order as 1 as having a rotational symmetry. So no, this figure does not have rotational symmetry. What about my Captain America? This is an interesting one. Okay, so here's the thing, just pretend that there is no star there. Okay, if it was just circles, then if I just turned it a little bit, it would match up. But because of the star there in the middle, that is a limiting factor until we match up exactly. So if I start turning and turning and turning, here we go, it matches up exactly right there. So it matches once, twice, 3 times, then 4 times, and then 5 times. So this tells me that yes, this Captain America mug has a rotational symmetry and order is 5. What about this rectangle? Again, can we keep turning until it matches up? No match, no match, no match, no match, no match, no match, no match. And then bam, when we are pointing it down. So we've turned 180 degrees and it matches. So that's 1 and 2. Remember, we just need the rotation, order of rotation to be more than 1. So it needs to be 2 and more, and it has rotational symmetry, and the order is 2. It matches 2 times. What about my favorite recycling pattern, recycling symbol? Here, when I start turning, it matches once, and then it matches again twice, and then finally I made a full circle my 3rd time. So yes, this recycling symbol has a rotational symmetry and with the order of 3. And by the way, you should be recycling. Now we're going to be taking some notes summarizing all the things that we've learned. So symmetry, both rotation and reflection can result in symmetrical images. Reflection symmetry is specified by 1 or more lines of symmetry. Rotational symmetry is specified by the order of rotation. The number of times the figure is the same while making a full 360-degree turn. Great, so that sums up the symmetry. Now we're going to be moving on to perpendicular lines. So first thing, I want you to tell me of A, B, C, and D, which of the 2 lines here represent perpendicular lines? Well, the correct answer is A. Why? Because perpendicular lines must intersect. Perpendicular lines intersect. That means they need to cross. So A and D both cross each other, but on top of that, they need to form right angles. And I think the common mistake is a lot of students mix up the perpendicular vocabulary with parallel. Okay, so let me show you a quick trick. When you write the word parallel, okay, do you see the 2 L's? Look at that. Okay, so 2 L's here, when you write those, they actually form parallel lines. Okay, so the parallel lines tells me that we're talking about 2 lines that will go on forever but never cross. While as perpendicular means there are 2 lines that must intersect, that means cross. But not only do they cross, but they form a right angle the way they cross. So in this case, this is the angle between the red line and the blue line is 90 degrees, and we indicate that using this square symbol that communicates that we're dealing with 90 degrees. So the correct answer is A. Alright, so with that, you're going to be working on card number 13 to 21, where you're going to be just practicing drawing perpendicular lines so that you can visualize it more clearly. Here we go. So card number 13 is just asking you to move the blue dot so that the 2 lines will be perpendicular. Remember, this is parallel lines. Okay, perpendicular lines cross each other, but not only do they cross, but they cross at 90 degrees. So the angle here between this blue line and the red line is 90 degrees, and that's about 90 degrees. One's going to be completely vertical, one's going to be horizontal. Okay, and then I go on to next card, and it tells me, oh, they've drawn the perpendicular line, and I was right on. My blue lines was perfectly spot on. Yay. Okay, now make these two lines perpendicular. Okay, now the red line is a little bit tilted, so can you still make 90 degrees? Remember, think about a cross when you are thinking perpendicular lines. Okay, so that looks like that's making about 90 degrees, so I'm going to check that by going on to the next card. I was a little bit off, just tiny whiny bit, okay, but slightly more or less, but I know what I'm doing. Okay, all right, then number 17, let's do one with help of the corner plane. Okay, now we have a diagonal line. Does that help me at all, or does that confuse me? Okay, so if they're going to cross here. Okay, does this help me? About that much, maybe. Okay, I was a little bit off. The grids confuse me or the grids help me. It's up to you. All right, then while placing the perpendicular lines, Sabrina sketched the two triangles on the graph. What do you notice about the triangles? Okay, so these are the slope triangles, right? So she said that it was +1 here and then +3 here. Here she's going to the left by 3, going up by 1. So it's 3, -3, +1. So what do you notice about the triangle? Well, this triangle and this triangle, they look like a rotated image. They are the same size, same shape, but the orientation has changed. It's actually a rotation of this triangle to this triangle by 90 degrees, as if I've moved it 90 degrees to the left counterclockwise about this point of intersection there. Roughly place your perpendicular line, then try using Sabrina's method to help you nail the location more accurately. Okay, so we want here, in this case, the rise is 2, run is 1. So in this case, I want the run and rise to be the opposite. So I want the rise was 2, so I want the run to be 2. Rise to be what? Run was 1, so I want the rise to be 1, and here we go. Okay, so let's try that. Okay, I was spot on. Here are the two perpendicular lines and two possible triangles used. See, 2, -1. So going from this point to that, I went to the left by 1, go up by 2, so it's -1 plus 2. Here from this point to that, I went up by 1, to the right by 2, so that's 1/2. So hopefully you'd have noticed that these two triangles. Okay, so this was card number 20, I believe. Okay, so it is a rotated image by 90 degrees counterclockwise. When I do that, do you see that this triangle and this triangle are rotated image of the other? Okay, and so slope of perpendicular lines. Some takeaway is that perpendicular lines are 90-degree rotations, really. Okay, it does not matter what the line is, how slanted or how vertical it is, it's a 90-degree rotation of the line. And slope triangles are also rotated, so that is the reason that slope is always rise over run. So for line 1, the slope will be +3, rise is 3/1. Okay, 3/1. For line 2, the rise is 1 and run is -3. So slope is 1/-3 or -1/3. Okay, so and notice the difference between the 3/1 to 1/3 and the negative. You should notice that what happened to these two fractions? It got flipped, didn't it? And this is what we call reciprocal. The two numbers are reciprocal, but on top of that, the signs also changed. It went from positive to negative. So rise and run, they switch places and the sign switches. And likewise here, for card number 21, you should have noticed that slope is 2/-1, and then slope of the second line is 1 over 2. Let's see.